Hello everyone, welcome to Brain Blitz Audios. In this episode of Cbse board exam, we'll be dealing with previous year questions of mathematics in Cbse board exams of past years. So here we'll be dealing with the third chapter in the syllabus of grade 12, and the name of the chapter is Matrices. Let's look at our first question. Express the following matrix as a sum of a symmetric and a skew-symmetric matrix and verify your result. So, how do we go about this? So, let's write A as our matrix. 3 minus 2 minus 4, 3 minus 2 minus 5, minus 1, 1, and 2. So the first step here is to find P. Now P is equal to half of A plus A transpose. So what we'll do is we multiply half to the original matrix, 3 minus 2 minus 4, 3 minus 2 minus 5, and minus 1, 1, and 2. And then we add it with the transpose of the same matrix. So that will be 3, 3, minus 1, minus 2, minus 2, 1, minus 4, minus 5, and 2. So here we are interchanging the rows and the columns to get the transpose. So now on adding A and A transpose, we will get half into 3 plus 3 is 6. That's the first term. So we add each of the terms here. Minus 2 plus 3, that's 1. Minus 4 minus 1, that's minus 5. 3 minus 2, that's 1. Minus 2 minus 2, that's minus 4. And minus 5 plus 1, that's also minus 4. Minus 1 minus 4 is minus 5. 1 minus 5 is minus 4, and 2 plus 2 is 4. So this is half times 6, 1 minus 5, 1 minus 4 minus 4, minus 5 minus 4, and 4. So usually many people try to multiply half into here, but I like to keep it as it is because it's way simpler when we are solving it later. So now we know P as half times this matrix. Let's find P transpose. So P transpose will be equal to half times 6, 1 minus 5, 1 minus 4 minus 4, minus 5 minus 4, and 4. And we'll do the transpose of this matrix, which will be actually equal to 6, 1 minus 5, 1 minus 4, minus 4, minus 5, minus 4, and 4. So even when we're interchanging the rows and the columns, it'll still be the same. So the matrix remains the same. So what it means is that P transpose is equal to P, which signify that P is symmetric. So the matrix P is symmetric. Now let's look at another matrix, Q. Now Q is given as half of A minus A transpose, which will be equal to half into 3 minus 2 minus 4, 3 minus 2 minus 5, minus 1, 1, and 2. And then we multiply it, we subtract it, so we add the transpose multiplied with minus 1. That is how subtraction is done in matrices. So that will be 3, 3, minus 1, minus 2, minus 2, 1, minus 4, minus 5, and 2. So now on subtraction, what we'll get is 3 minus 3 is 0, minus 2 minus 3 is minus 5, minus 4 plus 1 is minus 3, minus of minus 1, and then 3 minus minus 2 is 5, minus 2 plus 2 is 0, minus 5 minus 1 is minus 6, minus 1 plus 4 is 3, 1 plus 5 is 6, and 2 minus 2 is 0. So this is Q. Now what we'll do is we'll take Q transpose. So that is Q transpose will be equal to half into 0 minus 5 minus 3, 5, 0 minus 6, 3, 6, 0, and we do the transpose of that. So what we'll get is 0, 5, it's 5, 0, 5, 3, or a better idea would be to erase it so that we can write properly. So 0, 5, 3, minus 5, 0, 6, minus 3, minus 6, and 0. So if you look here, both of the matrices are the same, but the signs of the elements are interchanged. So what this means is that Q transpose will be equal to minus Q, which means Q is skew-symmetric. So the matrix Q is skew-symmetric. Now what we do is we add P and Q. So it's P plus Q. Now remember, we've kept half on both P and Q. What we do here is we take that half common, then we add the two matrices. Okay, so let's look. 6, 1, minus 5. This will be 1. Let me erase it. Then 1, minus 4, minus 4, and minus 5, minus 4, and 4. And then plus Q, the matrix. So 0, minus 5, minus 3, 5, 0, minus 6, 3, 6, 0. Okay, so on adding, P plus Q will be equal to half of 6 plus 0 is 6. 1 minus 5 is minus 4. Minus 5 minus 3 is minus 8. 1 plus 5 is again 6. Minus 4 plus 0 is minus 4. Minus 4 minus 6 is minus 10. Minus 5 plus 3 minus 2. Minus 4 plus 6, that is 2. And 4 plus 0, that is 4. Now we multiply half to each of the elements. So half of 6 is 3, half of minus 4 is minus 2, half of 8 is 4, half of 6 is 3, half of minus 4 is minus 2, half of minus 10 is minus 5, half of minus 2 is minus 1, half of 2 is 1, half of 4 is 2. So this will be P plus Q. But if we go back to our question, A is equal to 3 minus 2 minus 4, 3 minus 2 minus 5, minus 1, 1, and 2. And over here, P plus Q is also the same matrix. So therefore, P plus Q is equal to A. Therefore, the matrix A can be expressed as the sum of a symmetric and a skew-symmetric matrix. That is the end of our question. Now let's look at the next question. We're given a matrix 2, 0, minus 1, 5, 1, 0, 0, 1, 3. We have to find the inverse of the matrix. So let's take A as 2, 0, minus 1, 5, 1, 0, 0, 1, 3. In matrices, in order to find A inverse, what we do is we multiply I 2. To find A, we can express it as I times A. And I is the identity matrix. So when we multiply something to an identity matrix, it stays the same. So A can be expressed as IA. So using A is equal to IA, what we'll get is 2, 0, minus 1, 5, 1, 0, 0, 1, 3. That will be equal to I is 1, 0, 0, 0, 1, 0, 0, 0, 1 times A. So here we're not putting the value because now we're doing something else. So over here, what we'll do is we'll do elementary row transformations. We'll transform this A matrix such that it has the value of I. And the value of I will also change accordingly. And then at the end, what we get here will be our A inverse, the inverse of the matrix. So first things first, what do? The first thing we do is change R1 to 3 times R1. So we multiply the top row 3 times. So what we'll get is 6, 0, minus 3, 15, right? So 15, and then 1, and then, no, it's not 15, it's actually 5, because that only works on the first row. So it's 6, 0, minus 3, 5, 1, 0, and then 0, 1, 3. The transformation only affects the first row of both the matrices. And so over here, we'll get 3, 0, 0, 0, 1, 0, 0, 0, 1 times A. So this change happens here, and we can see the effect. Now, what is the next change we should be doing? Now, we'll subtract the second row from the first row. R1 changes to R1 minus R2. So therefore, what we'll get is 6 minus 5 is 1, 0 minus 1 is minus 1, minus 3 minus 0 remains as minus 3, and then the other rows don't change. And that's what happens here too. 3 minus 0 is 3, 0 minus 1 is minus 1, 0 minus 0 is still 0, and then 0, 1, 0, 0, 0, 1, that occurs. So our next change. Now, we need to keep these as 0. And in order to do that, we can add the third row to the first row. So R1 changes to R1 plus R3. So when that happens, 1 plus 0 is 1, minus 1 plus 1 is 0, minus 3 plus 3 is also 0. And then we have 5, 1, 0, 0, 1, 3. It'll be equal to 3 plus 0 is actually 3, not 0. Let's erase it. Yep. So 3 plus 0 is 3, minus 1 plus 0 is minus 1, 0 plus 1 is 1. Then we have 0, 1, 0, 0, 0, 1 times A. Don't forget to write the times A. Okay, so now the next transformation is of row 2. So row 2 changes to R2 minus 5R1. So when R2 changes to R2 minus 5R1, the matrix becomes 1, 0, 0, 0, 1, 0, and then 0, 1, 3. So what we'll get here is 3 minus 1, 1. That is still the same. Now, 0 minus 3 into 5. So that is minus 15. Similarly, we'll get plus 6 and minus 5. And then the third row is still 0, 0, 1. So now on to the next row transformation. And we have to change row 3. Row 3 becomes row 3 minus row 2. Let's erase it and write it properly. So row 3 minus row 2. Now let's look at what happens. So row 3 minus row 2. So row 1 still stays the same, 1, 0, 0, 1, 0, 0, and then row 2 remains the same, 0, 1, 0. At row 3, 0 minus 0 is 0, 1 minus 1 is 0, 3 minus 0 is 3, which is equal to 3 minus 1, 1, minus 15 plus 6 minus 5, and 0 minus minus 15, so that is plus 15, and 0 minus 6, so that's minus 6, 1 minus minus 5, that's 1 plus 5, so 6. Now, if you notice here, now this matrix is almost similar to the identity matrix, except for that 3. In order to discard that 3, we can't add anywhere or subtract anywhere during using elementary row transformations. So what we do is we transform R3 to 1 by 3 R3. So when we do that, we get 1, 0, 0, 0, 1, 0, 0, 0, 1, and that is the identity matrix achieved. So then what happens here? 3 minus 1, 1, minus 15 plus 6 minus 5, no change so far. Over in the third row, 15 by 3 is 5, minus 6 by 3 is minus 2, 6 by 3 is 2, times A. And so that is I. And to find I, what we do is we multiply A by its inverse. So A inverse A is I. And so this is similar to A inverse A. So from that, we get A inverse, that is our answer, the inverse of the matrix, as 3 minus 1, 1, minus 15, 6, minus 5, 5, minus 2, and 2. So that is our answer. And that ends this episode of CBSE board exams. That was our last question. For more of such tutorials and other useful and interesting content, please subscribe to our channel, Brain Blitz Audios. We'll be back with more useful and interesting content. Until then, take care, stay safe. Bye-bye for now.